Alright, so the next unit that we're going to be going to is Chapter 10, and Chapter 10 deals with, whoops, I'm on my eraser. Chapter 10 deals with chemical quantities, and what we're going to really be talking about is chemical quantities and ways to count things that are ridiculously large or ridiculously small to count. I always use the analogy, I say to my students, how about you not having to be in chemistry class the rest of the year? How about you not having to come to school here at Drape, and you can take the rest of the year off? But what you would have to do is count every tree in the state of Maine. Well, you know, just looking outside my window, it's probably an undoable task. You know, how can you count all the trees? So same type of thing here. When we're talking about molecules or atoms and amounts of things, it's ridiculously large numbers, ridiculously small. So that's what we're going to be using here. What we're going to look at first is, I want to just review what atomic mass and formula mass is, again, using the periodic table. So this is a nice little review. And atomic mass obviously deals with atoms. For example, lead, 207 AMUs. AMU stands for atomic mass unit. I'll just remind us, atomic mass unit. Okay, so it's not like if you have one atom of lead, it weighs 207 of something. It's atomic mass units. So again, when you think about the fact that a proton weighs 1.67 times 10 to the negative 24th grams. Same thing basically with a neutron, 1.67 times 10 to the negative 24th grams. And then of course an electron, 9.109 times 10 to the negative 28th grams. When you talk about one atom that has the protons, electrons, neutrons, we use the AMU. So lead, sodium, 23 AMUs. 63.5 AMUs for copper. Basically, you can round all the masses, all the atomic masses off the periodic table to whole numbers. I use copper, I'll use 0.5. Chlorine, I'll use 35.5. Basically, if it's right smack dab in the middle. Otherwise, you can round them to whole numbers. So that's atomic masses. Formula masses are for compounds. So compound like water has 18 AMUs. And again, how do we get that 18 AMUs? Well, hydrogen is 1, and we have 2 of them, so times 2, we get 2. And oxygen is 16. Again, we're rounding the whole numbers, so 16 plus the 2 gives us our 18 AMUs. Copper nitrate, 187.5. Just as a quick reminder, we have only one copper, that's 63.5. We have 2 nitrogens. So each nitrogen is 14, so we have our 28 AMUs. And we have 6 oxygens. Oxygen is 16, and we have 6 of them. So whatever 16 times 6 is, let me quickly, I could do that I suppose on my head, but let's take my calculator. We have 96. We add that up, and it gives us our 187.5. So again, knowing our amounts of things. I think I gave another one, or I don't. Okay, so that's atomic mass units and whatnot. What we're going to then take a look at is the next really important thing, and that's dealing with the mole. So the mole is a way of counting very, very large or small things. So what is a mole? Is a mole a little furry creature burrowing in the ground? No, that's not going to be the mole we're talking about. Is it a little thing on your face? Or this one? I think everyone's a little more familiar with that. So many people nowadays forget Cindy Crawford, but she was the supermodel back in the day. So that's not the mole we're talking about. What is the mole? Well, the mole that we're going to be talking about, I'm going to start with my next video. So let me just stop this one.